हेलो हेलो हेलो। अनुष्का, आवाज आ रही है? तुम लेट हो गए आज।
Yes, sir. Sir, just a second.
तुम सो गए थे क्या?
No, sir. सर आजकल एग्जाम चल रहे हैं ना तो
अच्छा, अभी चल रहा है।
हाँ, अभी फिजिक्स का है 19 को।
ओह,
नेक्स्ट ट्यूसडे।
अभी तो टाइम है। 19।
यस सर।
कल का एग्जाम कैसा हुआ?
सर सही था। पेपर थोड़ा लेंदी था बट पेपर सही था। थोड़ा वो एनसीईआरटी भी आया था
और
बट और बाकी तो पेपर हो गया था। एनसीईआरटी के क्वेश्चन ही सॉल्व करे थे मैंने। बस
हम्म,
पेपर थोड़ा लेंदी था।
हाँ, देखो, अगर तुम्हें एनसीईआरटी क्वेश्चन मतलब जो पेपर में क्वेश्चन आते हैं ना बहुत अच्छे से सॉल्व करने हैं ना, अगर तो उसमें कंफर्टेबल होना है तो थोड़ा सा लेवल एनसीईआरटी से थोड़ा अप रखा करो। वैसे तुम तो जेई के स्टूडेंट हो, जेई पढ़ते हो। अगर ये लेवल अप लेवल के क्वेश्चन ज्यादा करोगे ना, थोड़े से कंफर्टेबल रहोगे। ऑर्डर अपना ये फॉलो करा करो कि एनसीईआरटी क्वेश्चन तो तुम करते ही हो, साथ में जो दूसरे क्वेश्चन है ना प्रैक्टिस के, जो मैं देता हूँ या फिर जो मैंने बुक बोल रखी है तुम्हें, उनके क्वेश्चन करते रहा करो तो कंफर्टेबल रहते हो। ठीक है। ठीक है, मुझे लगता है आज स्कूल से ही नहीं आई है, लेट हो गई हो।
ओके सर।
तो अपन ने लास्ट टाइम में ये पढ़ लिया था ना, केसी और केपी वाले क्वेश्चंस। अभी अपन मैं तुम्हें डेल्टा जी वाले क्वेश्चंस दिखाता हूँ। डेल्टा जी पे कैसे क्वेश्चंस हैं। अभी ठीक हो ना तुम, मतलब फ्रेश हो ना? आज स्कूल
You
से
can
कितने बजे?
start.
हाँ, व्हेन डिड यू कम फ्रॉम स्कूल? अनुष्का,
So approx 2:30.
2:30 ना? ओके ओके। ठीक है, केमिकल इक्विलिब्रियम। पहले फर्स्ट ट्राई टू सॉल्व दिस क्वेश्चन। I should try solving this question. KP of the question is given to us and they are asking for the value of KC. Shouldn't be difficult for you. हाँ। क्या हुआ कनिष्का, नहीं आ रहा? कनिष्का, यू आर नॉट गेटिंग द आंसर?
सर हो गया सर। 2.00 आ रहा है क्या? थ्री
हाँ,
डॉट टू
2.0038।
समथिंग
हम्म,
ऐसा ही आ रहा है अप्रॉक्स।
नहीं सही है। द आंसर वाज एक्चुअली इजी ना, दिस क्वेश्चन वाज सपोज्ड टू बी इजी, बिकॉज kc is equal to kp is equal to kc into RT power delta, and that formula we have RT power delta n, where delta n represents the total number of moles of product minus total number of moles of reactant. So it will be 2 minus 1, 2 minus 1, so it will be 1. That means kp is equal to kc into RT over 1. kc is given to be 47.9. You have to multiply R and T with this. R is gas constant. Gas constant value they have given already. So it will be 47.9 to 0.083 into temperature is what? 288 Kelvin. When you multiply these, you get your answer. The answer that you are getting is 2.0038.
ओके सर।
Get this one. This way. Let's see. 47.9, 0.083 to 88. No, we are getting different answer. Are they taking the reverse reaction? There is something wrong. Acha, acha, acha. The value of Kp is given. Now, why I have put the value of Kc here? Kc we have to find. Na? That's why we are getting wrong one. Mhm. Kp is given to us. Kp is 47.9. Kc we have to find. R is, now we'll get the right answer. T is 288. Kc will be now 47.9 by 0.083 into 288. Check. Divided by 0.3. 577 by 288. Now you'll get 2.00. By mistake, I've assumed the value Kc. Acha, let me give you one question. This value I've given, na? So I wanted to give questions on uh, delta G. Where you have to go? First, try to solve this one. It's not a difficult one, but you will have to use this equation. This delta G naught I have told you na, earlier. That equation you'll have to use.
यस सर। ओके सर।
See this one. Just try to understand this question first. If you have any doubt in this, I'll clarify then. If you are able to understand, attempt it.
Okay.
See, one more thing, Kanishka. Here, whenever you are going to use that equation, na, delta G is equal to minus 2.303 RT log Kc, I have told you, na, this value. Now, that this we use here Kc whenever we are having concentrations given to us. But in this particular case, as you see here, they have given gases. So this equation in that case becomes delta G is equal to minus 2.303 RT log Kp. When we are dealing with gases, this equation becomes 2. Minus 2.33 RT log Kp. And when we are dealing with concentrations or liquid solutions, then this here the K becomes Kc. Okay,
Okay, sir.
this is for gases. This is for everything else. Now you can attempt it. निष्का क्या हुआ? Are you not getting answer for this?
तो बस हो गया. So is the answer is this 1381.8.
1381. 1380.
Okay. This much.
Hmm.
Some calculation
Some
error.
calculation error. Answer is 1380, but I think you have done everything correct. Some calculation mistake is there. Acha.
Yes. Okay,
After
sir.
this, we need to start. Now you will be able to solve the questions on this. Now, the next part is Lee Chatelier principle. Now, what is this Lee Chatelier principle? This principle says, see, this principle is actually like equilibrium. Means a body, means na, means every body in physics, every body tries to be in a state of equilibrium, right? Here in this Lee Chatelier principle, the system which is already in equilibrium does not want to disturb its equilibrium state, and whenever you do something that disturbs this equilibrium, it will try to neutralize it. Okay, means in short, Lee Chatelier principle says the system tries to neutralize any change in its equilibrium. Okay, it's like if you are sleeping, you want to sleep only, and you don't want to wake up until you're ready. You know, someone tries to disturb you, then you won't be disturbed. Or if you are doing something, if you are doing something and you are comfortable doing it, you don't want to you don't want to shift to any other activity because you like doing that activity. It's like that thing. So any system in nature or in any chemical reaction which is already in equilibrium does not want to shift its state because it's already in equilibrium. So whenever you do something that changes, tries to change or tries to disturb that equilibrium, it will oppose it. That's the simple thing. Now, okay, understood now?
Yes,
Language
sir.
wise you understood now? Okay. So in short, the Lee-Chatelet principle says a system wants to be in a state of equilibrium only. Now, what are the changes that can occur in a chemical reaction, in an equilibrium reaction? Possible changes are change in concentration, second is change in pressure, and third is change in temperature also. These three kinds of changes you can do in a equilibrium. Now see, now I'll explain you how the change actually tries to oppose it. How changing some concentration or changing pressure, the system tries to oppose it. How? And in that way, how you can predict which quantity will be formed more, which will be formed less. So first we'll discuss change in concentration. Take an example, H2 plus I2 is giving you 2HI. Okay, now I am changing the concentration. What I have done, this is a state of equilibrium. Now what I have done, I have increased concentration of H2. Okay, I have increased the concentration of H2. Now what
Okay.
will happen? Now see, it was comfortable. Now you have increased the concentration of H2. So what will happen? The concentration has increased, concentration of reactant has increased. So what will happen? Because more reactant is present, the uh, the reaction will try to move forward. Okay, normally. Yes, now concentration of H2 is increased,
Yes, sir.
so it will try to
Yes.
react more. It will try to react more, and normally it will move forward. But the cause is increase in the concentration of H2, and because of this, what happened? The reaction is trying to move forward. So what will happen? So to oppose this, the reaction will do what? It will try to move more backward. So increasing the concentration of H2 will result in reaction to move backward according to Lee-Chatelet principle to maintain equilibrium. Understood this thing?
Yes, sir.
This, see, usually here what mistake students do, they think when the concentration of reactant is increased, to decrease the concentration, the reaction will try to move forward. Okay, it will decrease the so the concentration will be decreased, but that's wrong. What will happen when the concentration of the reactant is increased? The reactants will try to react more, and natural tendency is, so because they are reacting more, they will form more product, so it will move forward naturally. But because the according to Lee-Chatterjee principle, the reaction does not want to change its equilibrium state, and the reaction is moving forward. So the reaction will try to move more backwards, so that the increasing tendency of moving forward will be neutralized. This is how we have to see. And similarly, if we increase concentration of HI, then what will happen? Reaction will move forward. Understood? See, now the next things, the change in concentration I have discussed. Change in pressure and change in temperature I'll discuss in the next class, because
Okay, sir.
time is getting over. Next
Okay,
class.
sir.
Let's end.